Greetings, math fans. All right, so today we are going to talk about something called intercepting the pole. Sounds very exciting. Intercepting the pole. So, who do we know that intercepts the pole a lot? Of course, it's non-denominational holiday man or person, right? Santa Claus. But you guys know the pole. If I just kind of sketch a picture here. The pole is this nice little point right here. And what can you tell me about that point? Okay, what is actually the only thing you can tell me about that point? I mean, can you tell me theta is equal to something? Well, no, you can't. I mean, theta can be anything, can it? Can it be 10 degrees, 20 degrees? I mean, that doesn't really matter. But what does matter? R matters. What is the value of R at the pole? R is 0. That is key, okay? R is equal to 0. Very, 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 very important. Okay, in fact, that's what all my examples are going to be based on. R being 0, because that's when you intercept the pole. Okay, so let's do some problems here. Basically, what we're going to do, again, we're going to set R equal to 0, and you're going to find theta. And so you're going to give me an answer, always R comma theta, so it's always going to be 0 comma theta. Always, always, always 0 comma theta. Okay, really, really important. Okay, so let's start out with the first problem here. If I said R is equal to 5 cosine of 3 theta. So you guys kind of need to remember this is a rose. Hopefully you remember that. Okay, and the petal length is 5, and this has how many petals? It's got 3 petals. Now, if you guys remember when I first taught you that, I'm just going to make a quick sketch and then we're going to do the problem. But if this is what the problem looks, or let's say if I graph it, and it kind of looks like this, and like this, and like this, and like this. Okay, graph 3. Remember what I told you? It actually repeated itself. It went around again, again, and again like that. Okay, that's a really bad rose. But it really went around twice. So it actually, if you count the number of times it hits this point right here, the pole, it actually hits it 6 times. Now this is going back to it's like chapter 5 or chapter 6 when I asked you to solve an equation, okay, when you had a 3 there, okay, you guys remember you had triple the number of answers, okay, triple the number of answers. We're going to actually do a problem like this, but I just want to remind you, you have triple the number of answers. So truly I have, if it's equal to a value, in this case it's going to be equal to 0, okay, you have, and there are 2 places where cosine is equal to 0, right? Isn't cosine of 90 degrees equal to 0? And isn't cosine of 270 equal to 0? Right, so there are 2 answers, and then you triple that number of answers. So you actually have 6 answers, which is what I just did here. I went around this, when I created this, this rose here, I actually touched the pole 6 times going around, right? Once to trace it, and then once to go around it again to actually just trace on top of it. All right, so let's kind of start all over here again with the problem. So the problem is R is equal to 5 cosine of 3 theta. Well, the first thing you're going to do is you're going to set it equal to 0. So 5 cosine of 3 theta equals 0. And then this is really easy, right? You just divide by 5, and you get cosine of 3 theta is equal to 0. And then you ask yourselves a question. Hey, cosine of what is 0? Well, as we just said before, equal to 90 and 270. So those are 2 answers. And then remember what I did with this back in the day? Okay, I added 360 degrees. I have my next set of answers. All right, and I'm not really going to explain it all over again, but really that 3 theta has to be whatever that value is, or the theta has to be between 0 and 360. So 3 theta has to be between 0 and 3 times 360. That's just to kind of refresh your brains a little bit why I'm adding that 360. So if I add 360, I get 3 theta is equal to 450, and I'm adding that to 90, and then 3 theta is equal to 360 plus 270, which is 630. Okay, and then that's one set of answers. Now I'm going to add another 360 because it's, again, triple the number of answers. So 3 theta is equal to, again, I'm adding that to 450, I get 810, and 3 theta is equal to 990. That's how I get 6 answers. Okay, now the last step, please don't put 90 and 270 and 450, because I would say, well, those are bigger than 360, the 450, 630, 810, 990. Remember what you have to do. The last step is you need to either divide by 3 or multiply by 1/3. I don't care what you do, it's the same thing. And then your final answer comes out to be theta is 30 degrees, 90 degrees, 150 degrees, 210 degrees, 270, and 330 degrees. Okay? Now, your final answer needs to be where I even told you. I wanted an r comma theta. Okay? It's got to be in a coordinate form. Has to be. Otherwise, you won't get full credit for it. So, again, remember, r is 0. That's what we did. We set it equal to 0. So your answer is going to be 0 comma 30 degrees, 0 90, 0 150, 0 210, 0 270, and 0 330. Okay? Those are your 6 answers. That's where it crosses the pole. Not that bad. Let's do another one. Okay, just again, a little practice here. Let's do one with sine. So r is equal to 5 sine of 2 theta. Now, that's great for you to know that this is, again, a rose, and it's 4 petals. Now, this one does give me 4 petals, so I have double the number of answers. It's going to have 2, so I really have 4. But it's 4 petals, so I don't have to worry about it. You just have to remember, when you have a 2 theta here, or I don't care, let's just say it's 10 theta, I know I'm going to have 20 answers. Okay? If it's 5 theta, I'm going to have 10 answers. So it's always double the number. All right? Not number of petals. Don't get that confused. Okay? This 10 theta means I have 20 petals. This 5 theta means I have 5 petals. An odd number is the same number of petals. An even number is double. Okay? So, anyway, let's go back to our problem here. It's going to be 5 sine of 2 theta equals 0. Now, this is actually a common mistake, as kids sometimes make this a 1. Okay? They set it equal to 1, or they set it equal to 5, right? Because they set it to the length of the petal. That's only when you're graphing it to figure out the end of the petal. It has nothing to do with finding the pole. So we set it equal to 0. And of course, we divide by 5, and we get sine of 2 theta. It's always going to be, sine of 2 theta equals 0. It's always going to be equal to 0, always. And then you're going to say, hey, sine of what is 0? And you're going to say, oh, it's at 0 and at 180, right? Sine of 0 and 180 is 0. And then what do? I add 360 to that to get my next set of answers. So 2 theta is equal to 0 plus 360 is 360, and 180 plus 360 is 540. Okay, so that's my second set, because remember, I have 4 total answers. And then, of course, my last step here is to multiply this by 1/2, or divide by 2, and I end up getting theta is 0, 90, 180, and 270. All right, but that's not my final answer, because you need to set r equal to 0 and give me 0 comma that theta. So it's going to be 0 comma 0 degrees, 0 comma 90 degrees, 0 comma 180 degrees, and 0 comma 270 degrees. Okay, those are your 4 answers. Okay, very, very important. Got to be coordinates. Okay, I want to do one last problem here, math fans. What about this one? R is equal to 2 plus 2 cosine of theta. Well, what is that? That's certainly not a rose anymore. It's cardioid. Or a nice little heart. How romantic. So you're going to do the same thing. You're going to set r equal to 0. So let's do that. It's 2 plus 2 cosine of theta equals 0. And then I got to solve for it. So I'm going to subtract 2 from both sides. I get 2 cosine of theta equals negative 2. And then divide by 2. So I get cosine of theta equals negative 1. Okay, so there's only one answer for this. There's only one place where it's equal to negative 1. So cosine of what is negative 1? Well, cosine of 0 is 1. Cosine of 180 is negative 1. So theta equals 180. There's only one answer for this, math fans. Okay? And so your answer is going to be, again, 0 comma 180 degrees. That's it. So if you remember, when you actually graph this, the graph looks something like this. Kind of like this. This. So it only actually crosses it one time. Cross the pole one time, and that happens to be at 180 degrees. If you'd actually sketch it out, and you do your, remember when you sketch it, you pick values of theta, and when theta becomes 180 degrees, you would go 2 plus 2 times, oh, negative 1. Oh, that's equal to 0. Well, there it is. It's hitting the pole at 180 degrees. Okay? So that's it, math fans. Kind of a quick lesson, but that is basically intercepting the pole. You don't want to spread this around too much because not many people cross the pole, and a non-denominational holiday person would not be happy if you gave away all the secrets on how to intercept the pole. Okay? Unless you talk to maybe Rudolph or someone of the other reindeer. Okay, that's it, math fans. Have an outstanding day. Adios. Goodbye.